Welcome to chemistry class with an Christopher GK. Of course, your usual chemistry teacher. This video, we are going to consider the topic titled coal. We are going to look at the topic coal. In the last video, we talked about carbon. And one of the amorphous carbon is this. So we are going to look at coal as a topic. It's expected by the end. These are the contents we want to look at, things you expect to learn by the end of this particular video class. These are, you are going to learn what coal is, the types of coal we have, destructive distillation of coal, then gasification of coal. We are going to consider coal, the types, the destructive distillation of it, and the gasification of coal. So we're going to follow them one after the other and run down the class. So first of all, look at a glance, look at this particular picture. Look at the image. It's an image of coal deposits. And what does it mean? What does it mean? What can we say about coal? How does it form? And how does it look like? As you can see the image. Now, coal is defined as having more than 50% by weight carbonaceous matter produced by the compaction and hardening of altered plant remains. 50%, at least 50% by weight or 70% by volume carbonaceous matter produced by the compaction, compression, and hardening of other plant remain when plants die. When plants die and they are being subjected to high temperature and pressure over a long time, over a long millions of years, it formed this. So this is the result of complex chemical and physical changes that took place when the remains of big forest trees and vegetations were buried under the ground millions of years ago, under great pressure and temperature in the absence of air. Of course, under the ground. And the dead materials, trees and plants that have been subjected under heat for millions of years ago, of course, it has decayed and been subjected under high temperature and pressure in the absence of air. Such thing called coal is being formed. Still remember, millions of years. It's not just today. It's not just 1 year. It's not 2 years. It's not just 100 years. It's thousands, millions of years. It's dead materials, vegetations. They are the things, trees and the living things that you see when they die, and they have been subjected to a high temperature and pressure. Of course, the land beneath the soil here is hot. So it gets formed, what we call coal. Now, different varieties of coal arise because of what? Differences in the kind of plant materials. Of course, we have so many things, so many plants, so many trees that do die. And when they die, their decaying ability or the things they will change into are not the same. So because of that, we will have different types of coal. And the degree of even their qualification, they are not the same. So, and even the range of impurities they contain, they are not the same. Because of that, of different plant nature, different degree of their qualification, and the impurity they contain varies. Because of that, we will have different types of coal in existence. So, what are the types of coal? Types of coal, what are they? Number one, we have PEAT. Number two, we have lignite. Number three, we have bituminous coal. Then number four, we have anthracite coal. So these are the four types of coal we have. And we'll look at them one after the other and see what they are and the range of their purity and their usefulness to us. Now, first of all, let's look at the first one, PEAT. Now, PEAT coal. This particular coal is a soft organic material. Of course, all of them, they are all organic material because plants that we see around us, they are all living things. So it's an organic material consisting of partially decayed plants, and in some cases, deposited mineral matter. Sorry. When peat is placed under a high pressure and heat, it becomes coal. Peat is not actually coal on itself, but rather the precursor to coal. So peat is just like what leads to, when it develops more, it forms a coal. So it's just like a preliminary part of coal that when it's been now subjected to a high pressure and temperature, that is high heat, it will not change, it becomes coal. So it's partially decayed plants and some deposits of mineral matters. The next one is lignites. Of course, lignite coal are also known as brown coal. It's a coal. So it's the lowest grade coal with the least combination of carbon. Lignite, of course, is a coal. The peat is also a coal, but when it's undergo a complete change, when it's been subjected to a high heat and temperature, heat and pressure, it will not change to coal fully. Now, this one is also a coal, but it's a low-grade coal. And is mainly used for electricity generation. Of course, we do hear that we use coal to generate electricity. So we mainly use lignite to generate electricity. The carbon content of lignite ranges from 65 to 70%. Carbon content of lignite ranges from 65 to 70%. But everything, the coal we are talking about is carbon. All the types we are talking about is carbon. So it's carbon we are talking about, but the carbon content now is what we are talking about, that this one ranges from 65 to 70% in abundance. All right, bituminous coal. This bituminous coal is also a soft coal, but is the second highest quality of coal with a carbon content that ranges from 78 to 86% in abundance. The high carbon and low moisture content of this particular type of coal makes it ideal in the production of steel and cement, as well as in the electrification or electricity generation and coal production. And the coke production, number one, we have one of the types. One is peat, second one lignite, third one is bituminous coal. Then lastly, we have what? We have anthracite coal. So this is a hard coal. This is a hard coal. It's dark black form of coal. It's a dark black form of coal and is the highest quality coal. Is the coal with highest quality. It is very hard and it has low moisture content and a carbon content of nearly 95%. So it's nearly more of carbon. It has the highest grade of coal. And anthracite is used for space heating, as is one of the cleanest type of coal to burn, producing less smoke when burned, producing less smoke than other types. Of course, is the hardest quality is dark black form, and it has the highest content, carbon content, 95%. And when it burns, it produces less smoke than other types. So these are the 4 types of coal we have, and we have looked at them. Now, next thing we need to look at is destructive distillation of coal. Destructive distillation of coal. When coal produces valuable raw materials for the chemical industry through this particular distillation. When coal is heated to a very high temperature in the absence of air, It decomposes to give 4 major products. Destructive distillation of coal has to do with heating coal in a very high temperature and pressure in the absence of air. That is what we mean by destructive distillation of coal. And when coal is being heated in such a way, in absence of air, in a very high temperature and pressure, it produces 4 main products, useful products. And what are they? Number 1 is coke. Number 2 is ammoniacal liquor. Number 3, coal tar. And then number 4, coal gas. These are the 4 distillative distillation of coal products. Destructive distillation of coal will give us these 4 products. So this process is called destructive distillation of coal. What is it? The heating of coal in a very high temperature and pressure in the absence of air. That is what we mean by destructive distillation of coal, which gives us these 4 products. All right, you're going to be taking a look at each of them. What is coke? When you hear coke, what does your mind go? Or what do you think? Coke is a non-volatile residue left behind after the destructive distillation of coal. I'm going to show you a picture or image that will help you to understand what we mean. It's a non-volatile residue left behind after the destructive distillation of coal. It contains about 95% carbon and 95% carbon and burns smoothly without smoke. Smoothly without smoke. It is used as both industrial and domestic fuel in the manufacture of gaseous fuel and in reducing, also serves as a reducing agent in the extraction of metals. So coke is very, very important. We use it as a reducing agent in the extraction of metals. We use it as fuel both in industry and in domestic use, and also in manufacturing of gaseous fuel. It contains 95% carbon and burns smoothly without smoke. Coke, we are talking about. The next one is what? We have coal tar. Coal tar, of course, is very, very common around us. Coal tar is a thick black liquid. It's thick, very thick and black. It is used in the synthesis of useful chemicals such as disinfectants for killing insects, pests, and microorganisms, explosive for blasting, drugs, perfume, dyes, synthetic fibers, and solvent for rubber and even paint. Coal tar, of course, and it's being used. We see them. That is what we use even in around us in these areas we have pointed out. Even the coal tar is being used in our roads. We see people that are tying road, is being also used there. We see that thing we call coal tar. Coal tar is gotten from the destructive distillation of coal. All right, we have another one, coal gas. Still remember, we have what? We have coke, we have coal tar, we have coal gas. Now, coal gas, what is coal gas? Coal gas is a volatile component. When we talk about coke, we say that coke is non-volatile component. It's a non-volatile compound that we do, substance we have there. Coal gas is a volatile component in destructive distillation of coal. And of a mixture of gases such as hydrogen, carbon dioxide, ethane, and small amount of impurities such as sulfur dioxide, hydrogen sulfide, and all of that. So it's a volatile component, but it mixed up with several gases that will have small part of all these, maybe hydrogen, carbon dioxide, ethane, and some impurities like sulfur dioxide and hydrogen sulfide. Coal gas is used in lighting, heating, and as a fuel. We use this in this area, and the final one is ammoniacal liquor. What is ammoniacal liquor? Ammoniacal liquor is a solution of ammonia in water. Ammoniacal liquor is solution of ammonia in solution, and it is used in preparation for ammonium tetraoxosulfate 6, which is used as a fertilizer. So these are the products that we have in destructive distillation of coal, and they are very, very useful to us. Now let's look at this. Destructive distillation of coal. This is the process that the setup or chamber in the industry that enables us to get these products, subjecting coal in a very high temperature and pressure in the absence of air. In order to get coke, look at by the left-hand side, we see coke as a deposit there. After that, we see coal tar in the condenser. Then after that, in the scrubber, we see ammoniacal liquor. Then finally, as the gas, coal gas, we see it there. All right. The next thing is gasification of coke. Gasification of coke. To gasify coke, we have talked about coke, what it is. So in gasification of coke, we're going to look at producer gas and water gas. Producer gas and water gas. What is producer gas, first of all? Producer gas is a combustible gas manufactured by blowing of air. This one, blowing of air through a bed of hot coke or coal. Still, no, when we talk about coke, we are talking about coal because we get coke from coal, destructive distillation of coke, and all of them, they are all carbon, such that the fuel is completely gasified. Blowing of air is being blown into the coke chamber. The gas obtained from the coke consists mainly of what? Mixture of carbon dioxide, hydrogen, with the nitrogen from the blacks of air. From the blacks of air. So blowing of air into the chamber of coke is how this particular producer gas is being formed, and it mainly consists of carbon dioxide, hydrogen, and nitrogen from the blacks of air. Now, look at what I'm just trying to say. Carbon, blowing air, of course, inside air we have oxygen and nitrogen. That is what we mean. Oxygen is there, nitrogen is there, which is air. Then it's going to producer gas is made up of, the compound of producer gas is carbon dioxide and nitrogen. So producer gas is made up of, it's a mixture of carbon dioxide and the nitrogen is producer gas. The air in the oxygen in the air oxidizes the coke to carbon dioxide, of course, with the liberation of a lot of heat. You can see heat liberated there, while the nitrogen is unchanged. You can see nitrogen in the air is still unchanged in the product. Some carbon dioxide formed are reduced by the coke to carbon dioxide. The production of producer gas is an exothermic reaction. Exothermic. That means heat is being given out. Heat is being given out to the surrounding. Producer gas is used to heat furnace reactors during the manufacture of zinc and coal gas. It is the source of nitrogen for the manufacture of ammonia during Haber process. Of course, we see hydrogen here. We use this particular producer gas as a means of producing ammonia, nitrogen, which is needed in manufacturing of ammonia in Haber process. Once again, still remember that the components of producer gas is carbon dioxide and what? Hydrogen. These are the two things that make up what? Producer gas. Now the other gas is what? Water gas. Water gas is a mixture that contains equal volume of carbon dioxide again and hydrogen. But producer gas is carbon dioxide and what? And the nitrogen. But water gas, carbon dioxide and hydrogen. It is prepared by what? Steam over white hot coke in the furnace at about 1000 degrees Celsius. This one now is when water is being allowed to pass over coke. But the other one, that of the producer gas, is heat, is air, is being supplied to coke. is being passed over it. This one now, which is water gas, is water is being allowed to pass water, which is steam, passing over coke. It's going to produce carbon 2 oxide and hydrogen gas, which two of them give us a water gas. That is what we mean. Of course, heat also is there, but in that this here, heat is being absorbed, which is endothermic reaction. The reaction is endothermic. That means heat will be absorbed to the system, and the coke quickly cool because the heat is being absorbed. It will cool to the temperature too low for the reaction. Water gas is used in the manufacture of hydrogen, methanol, and butanol. Still remember, component of water gas is carbon 2 oxide and hydrogen, while the component of producer gas is carbon 2 oxide and hydrogen. How does it form? Blowing of air, supplying of air to coke or coal, as the case may be. That is how it's being produced. And inside that air, we have oxygen and the nitrogen there. And it gets produced. It's being produced in the furnace, while this one is when steam, which is water, is being allowed to pass over coke, hot coke. It produces a water gas. All right, let's take a look at this. For producer gas, in order to produce producer gas, this is coke. Of course, all of them have to do with coke. In order to produce coke, by the left-hand side, you can see, you are going to open valve S, valve X, which is air, look down, X. You supply air. Then you close Y, close valve Y in the right-hand side. And when air is being supplied, of course, it's going to blow over, enter there, and meet the coke where it is. And that is how producer gas is being formed, is being produced. But if you want to produce for water gas, you open valve Y, which is in the right-hand side, and close valve X, valve X, the two of them. You close it, and the water will be supplied. Steam will be supplied to the coke, and thereby it produces the water gas. So just like as we explained, blowing air into the chamber of coke gives what producer gas. But when water is being supplied, it's being allowed to run over the coke, is going to produce what? Water gas. The component of water gas, once again, is what? Carbon 2 oxide and the hydrogen. Component of producer gas, once again, is what? Carbon 2 oxide and the hydrogen. And the nitrogen, carbon 2 oxide and nitrogen is for producer gas. All right. For further inquiry and discussion, do where to get across to me through my phone line or WhatsApp line, +234 80 655 732 29, +234 80 655 732 29, or send me an email through my email address. Email at christo116@gmail.com, at christo116@email.com. Still remember once again to give me comments. We need your comment in this particular class, in this particular video. We want to hear from you. Thank you for listening and being part of this particular class. And remember, thank you once again